Hello, everybody, and welcome to these streams by the one, the only, the soon to be melted down by the heat wave, the prefect, Dargent. So, what do we have for the stream today? Well, no surprise, we're going to continue with the stream from yesterday, which was a new rewrite of Impulsive compressor. And the first thing that we wanted to start with, sketch English there, is creating a mock encoder. Yesterday we gave the reasons, but for those who didn't join, the basic idea is that we're going to work in project mode. So we're going to build this compressor and probably many other compressors using Kanban dashboards. So cards saying what are the things that we want to do. And we are in the progress of implementing that mock encoder. The reason why is that it will give us a nice way to start testing the encoder, also the possibility to create a mock decoder that pairs with the make encoder, so we can create the decompressor without even touching files, and at the end adding that extra layer of the buffering, the command line interfaces, etc. And so for this mock encoder, there are 4 steps that we're going to do. Yesterday, we built up the project here in Codeberg, my local machine with Rust and Kate as an editor, Git, and so on and so forth. And we wrote the first version of the encoder that has a documentation, and it also has a test. All right, so before we start with the next steps, which are moving the encoder or part of the API of the encoder into a trait plus error management, a couple of announcements. First, I know the audio from yesterday was kind of terrible. The reason why, I figured it out just as I closed the stream. But basically, I had my speakers, my desktop speakers still on, powered on, and in more or less close proximity from the mic. So the mic was picking up, and because of the filters that I have in OBS, instead of creating an echo, it gave this crappy audio. So I have added to my pre-session checklist to check that the speakers are turned off, which they are. Secondly, the first stream that I do at this hour, which is 3 hours later than I do as usual. I don't know if this time is going to work better or worse. According to Twitch, this is going to be worse. But obviously Twitch doesn't need to start the stream in the middle of the afternoon during a heat wave with little to no fans or no AC. So for the moment, this is the time slot that I have. And this time is for 3 hours, because I have figured out that if the last 4 or 5 streams had have been lasting for over the 2 hours that I had scheduled, might as well increase those slots. Speaking of the schedule, the new schedule is still a work in progress, but what it is true is that tomorrow, I know that I typically stream on Sundays, but tomorrow there will be no stream. And by contrast, I'm going to start streaming over the work days. So there will be a stream on Monday, probably Tuesday and Wednesday too, even though the weather report for Tuesday and especially Wednesday is terrible. But I will be streaming on Monday, so not tomorrow, in 2 days. And that's all for the announcements. So let's start with the mock encoder. So why trade? Why error management? So this a mock encoder. The reason to write it is that later when we create a real encoder, that encoder can be swapped out by this mock for testing, debugging, what have you, right? So the API for this encoder and the real encoder has to be the same. So it makes sense that in order to standardize that part of the API, that the PII is expressed in a thread, right? So if we create a thread, by the way, something that I have seen in the standard library for Rust is that traits are typically represented with verbs. So you have read, write, display, and then implementations can have a noun based on the verb, like a reader, a writer, or in this case, an encoder. So I'm going to name the trait as echo. So the next step is to move into the trait parts of the API that are going to be common to all the implementations. So obviously, new depends on the implementation. Result is only for this implementation because it's providing us with access to the vector in which we are storing the mock output. So it is these three methods that are going to be, at least for now, the API for the trait, right? So inside that trait, we don't have bodies of functions, and there is no mention of public because traits define public behavior. There. So this would be the API, but if you think about it, all three tend to panic. And let's imagine that we implement an encoder, so a class, actually, a crate that has a different implementation of this encoder. Not a crate, I was right. Another struct, another type of objects that implement these traits. That is actually writing, and is writing to a file, to std out, to a network socket. Well, are we going to create all those implementations, or are we going to take advantage of the write trait, right? And the write trait write is implemented by, as you can see, by files, by TCP streams, std out, stdr, etc. So if we make our encode trait kind of assume that the implementers are going to use the write trait to actually write things in whatever place they want to, then it turns out that an implementer that is trying to write a reference to write a literal is going to call write or some of the methods provided by the trait. And that means that instead of panics, now we have a result type. The standard IO result, which is just a result of whatever and standard IO error. So it would make more sense that these methods or these trait functions return also this type of results. So let's start with to add that to the three functions. Okay, because again, this makes this this trait kind of future proof for future implementations. And as now, as you can see, we are now with a trait that is going to also add to our mock implementation error management. Why? Because obviously what we're going to do now is to split the implementation into the proper implementation of the encoder and the implementation of the trait class. You know, we don't need this documentation because it's documented in the trait itself. And of course, now it's going to complain. Check it out. That we are not returning anything. We are not compliant with the prototype of the trait. So let's add that to the three functions. Perfect. So that's now one thing. The second is obviously that we are not returning anything and that we should change these asserts with returning errors. Now, let's take a look at IO errors. And there are two ways in which you can build an error. One is with the new method in which we provide an error kind and optionally a message. We're going to add a message. Remember correctly, new, yes. So error, is passed on another error in order to make the cascade. But as you can see, you can use a string, because a string implements, or not a string, an str. str implements error, and basically it is printed out as the error message. So that's what we're going to do. But of course, that means that we need to use some error kinds. The library says, okay, instead of that, use this other method called error, which is basically an error new in which the error kind is other. That being said, if we go through the list of error kinds, there is this invalid input. That means a parameter was incorrect. So I think that for the checks that we're going to do instead of the assert, it makes sense to use invalid input. So basically, what we're going to do is if some minutes f, let me do this, and we return again. And if not, now we'll return an error, which is an IU error new of IU error kind invalid input. With the message error messages typically start with lowercase. This is explained in the trait, if I remember correctly. Error messages are typically concise, lowercase sentences without trailing punctuation. So concise could be something like what? Because, oh, sorry, this is not actually an invalid input because here we don't have any input. We could use unexpected end of file, but I don't want to, because that is actually an error that can happen when you write. For example, you write into something that has a limited space. So let's take a quick look to see if there is maybe it could be storage full, but I know that you end up with unexpected end of file in many cases. This is the one that I was saying. Unsupported. Why unsupported? Cannot encode EOF. And that's all. All right, that would be the new method. However, instead of that, we're going to do the typical thing about negating the condition, swapping out in a return here So this is flashed. Yeah. What I'm doing wrong. Expected. Nothing. Found result. That's not correct. Oh, that's going to make more sense in a second. All right. So why am I doing this? In this specific scenario, I cannot see why this test needs to be done in production, right? The user, while they are developing their compressor, they are going to configure the encoders to either use EOF or not, depending, as we discussed yesterday, on whether the compressor has another way to find out where the end of file is. I think it's something like that. Conditional compilation. And there is you see this one, debug assertion. So the thing is that if you use this attribute applies to a function. So not on a block of code, but the macro is actually, you can write whatever you want. So I think we're going to use this one. So basically, we're going to say if the configuration includes test asserts. No, debug assertions. Debug assertions. Then we run this piece of code. And that's all. All right. So this is something new that we have learned today, is having code that is conditional during compilation. So this will not happen in when the target is production. So when it is compiled with optimizations. So obviously this is one optimization. We're not going to check for this. And the same, we're going to do the same with the other functions. Why? because when the compressor is well written, it can only send valid lengths and distances, right? However, what we're going to do here, we're going to change a little bit. The condition is that if the length is 0, now we're going to actually use the invalid input error, and we're going to say length is too small, and we're going to copy the same for the distance. Now, this is more important because actually, if you were here for my last graph, the previous streams where I implemented this compressor, for a reference, the minimum length is actually larger than 0 because 3, 4, it changed. So in the real encoder, this check is going to be quite different. So of course, no, that we don't need this. Now we have this done. And for the last method, just need to check if the literal, sorry, not self, if the literal is empty, then it input empty literal. Easy. All right, so now this part over here should work. This never read. Yeah, this red. It is red here. Oh, because I know it cannot see it because of this. That's fine. And the trait encode is never used. And that's correct because it is well, it should be used here. So now, what we need to do, so the result is a news. In this case, but instead it's going to be news. And now you can see that we don't need a new function that panics. Instead, we create a new encoder. And now we're going to assert that this is an error. That's a function that it is. So now we don't need this. And similarly, we don't need to do the rest for the other methods. Now, the issue here with this assert, it is that I will be asserting only that is an error, not what error is. I don't mind a lot here in EOF because EOF is very easy to write. But what is there is a freak accident and we can actually add a symbol to a vector, right? There could be a problem there, but that's for a test in the real encoder. For our encoder, it should work. All right, and lastly for the reference, so now the stream is more quiet than it was in the past. I was looking at the audio yesterday that again had very bad audio and there was also noise. So I have done a lot of tests today and I had to add a noise suppressor that is quite potent. Here, a single keystroke, which was something that made the stream more lively, in my opinion, because that's not going to work, at least not at the moment until I find another solution. I'm going to come back to the origins in which we had some music. So let me check if, because that's another thing that I had to change. Yes, now the music is almost not audible, which was worth me. Let's turn up this a little. All right, so let's finish this, shall we? So we have, we're doing the test where everything fails. Okay, and for write reference, we actually have inferior modes in either of the parameters 0 All right, so as you can see, another advantage of using proper error management is that it makes the tests easy to work with. I'm going to add some comments and change the code a little bit. So first we're going to test sending EFF with order that is being disabled phase. Just this one. And now yes, this is a test. This is a simple successful test. There's little else to add because the method doesn't have any argument, so there's nothing else to test. Let's see, again, going to everything. This is actually an edge condition test. So and this is my user case. And for this, yes, we have actually two edge conditions, at least for this encoder, and at the moment. And then we have an initial case. And there we have it. So now it complains that the trait is news, but that doesn't make sense because we're implementing encodes for encoder. And that needs EOF is never read, which is kind of true because it is only read on conditional code. So this second one is always going to be a hassle. Index attributes in swap. I know it is complaining that it's not that it's never read, because it's written it is never read. collection is never read. So I don't know how to check this. So big P, it's that it's no, this is about creating the links. There we go. Compiler. So yes, this is the name, diagnostic structure, error codes, explain. Or error index. No, we don't have one. Error formattation. Does it work? No, it doesn't. So, let's see. You see here, when we have an error, it gives the error. But here, because warning, when the ring, it's the definition, the training linked. All right, let's try that. So it is actually, let's see, so I see URS. There. When this doesn't work, because it doesn't have a main function, and there is a solution for that. There was a fix that was shown about that says that with this option the first error becomes a bug, so it continues. Equal that. Oh. So this is not going to work. All right. Now. These are leads. Whoa, that was much more than I expected. Oh, Dave can be interesting. Even if it's a macro. Okay, let's do that. And we can do that too. We still don't have. Promise is not giving us the link name. Cargo check help. Cargo check. Message format. JSON diagonal. JSON. All right. Yeah, I know that's a message. So message render warning field is never read. Answering this stroke needs message type. Message never read response. Name is primary label for this stroke. This is, yeah, code that code. What? So let's move on. One. No, I don't think it's no one. So no word doesn't exist. If from attribute, valid forms for the attribute are ignored reason. Sorry, I'm still new to this. Hello. I'm so out of shape with regards to Rust. Stay me forever. There it is. So this trait, yeah, that's something that we're going to solve. Exactly when? When we implement it as a module. I think that by having it in a different module, it understands that it's a library. So it doesn't matter if it's not used, it could be used. In fact, this is going to be used because the first thing that we're going to do is to create a module just for the encode trait. And we're going to need this use. So this module that is going to be encoders is right that how do we word it? That is not exposes the API, is that it it normalizes as to VOD. Structures that it formulates, that it you know what, let's go back to the correct trait. Add trait for object. Trait for objects enabled LZSS symbols. There. So now we need to add it, which I think, if I remember correctly, is with mod. Back mode encode. Yes. So now the trait goes out. Trait encode is never used. And the error message is what? Won't give me the error message. Nope. Oh, the trait create encode exists, but is inaccessible. And now it's private. Oh, that's why there was an error there. Oh, I was wrong. No. And here it says there is a method write-off, but with different arguments. What do you mean? It's an implementation. It builds. Rabbit with bunkers. Method is available for encode here. All right. That is the problem. That's the solution. The problem was that the tests mod couldn't see the trait. Now everything works. Peachy. Perfect. So Lastly, we need to create another module for the encoder. However, if we think about it, let me check. Sorry, one thing that I'm looking at. So CPU 4%, no drop frames. Yeah, it's okay. Okay. So what I'm thinking of is that the mock decoder is also going to be showing this. So we have two options. One is we create 3 modules, one for the symbol, one for the encoder, and another for the decoder. Or we just put everything in the same module. Even if we take into consideration this, I think we can take a hybrid approach. We're going to try that. So I'm going to create a new file. That is going to be about mock artifacts for mock encoder decoder. At the moment, we don't have this mock encoder. It's this compressor. Like compressor. And it's going to be called mock. So encoding, decoding, coding. Has both the potential of both the encoder and the decoder. Okay. And mode encoder. And what we're going to do is there is everything the same file. Does it make sense to have all of this into same file? I think so. No, I thought we still needed. I mean, we need it. Yeah, but the problem is that it can one day use create code okay. Right. So now we have the library. We have this. No. EP says everything's right. B says everything's all right because a library there is not much to do. Test passes with all 3 tests. And now we have the crate that has 2 modules, one about the trait and the other about the coder. The trait has the documentation is wrong. It doesn't panic anymore. So let's solve that. Errors. Method returns error kind unsupported. Error kind legality. Yep. And I knew that that was a thing. So let me move this to other. So we can close this. And now the rest of the doc. So this basis is copying. I know that there was a way. What's an alias? Oh, this is. Attribute level, level. I'm almost sure that it knew how to link. And you can refer to anything in the scope. The stock also supports linking to all primitives in the standard library. The primitive types. Okay. And using fragment specifiers. So that's one way to do it. And okay, so let's try. What about the backticks? Yeah, I like this. It's not like errors. All right, so and that is an implementer for the encoder encoder. Perfect. Everything is linked. So in the modules, in the encode module, we already have the trait. And in the encoder, we have the symbol enumeration. And the trait implementations, debug and partial equality. And for the encoder, Since yesterday we have not added any functionality, we have modified source files, we have refactor, we have the documentation, but that's not neither here nor there. So yes, it's going to be a refactor. Refactor. Well, we actually did one change that impacted the behavior. Is the error management. And then it says to use imperative. Add image to so let's explain what a frat. It's not fatality, it's a feature. So these changes will be here or of include cause to return errors instead of panicking. Also, refactors with a mock encoder in its module on its pose common goes into a new thread. Sign off. Great. Alright, so now here locally we have two commits in this branch. So if I remember correctly, next step is to push the branch into the remote so we can create a pull request. But there's something new in the channel that I want to try. Oh, the alert is not working. I need to fix that. So as you can see in the chat, I have redeemed the stretch redeemable. I've done this with channel points. So when you have enough channel points, you can ask to stretch to, but I don't know why it's not showing. I will need to make another. So I know the alert box source is here, so I don't know why it doesn't show. In the alert box. Okay, so stretch anyway has been redeemed by me. So let's do that. Meaning that I will see you in 2 minutes. And we're back. All right. Identification. information. And turn down the volume of the music. And let's continue. So, pull request doesn't work. Why? Because you cannot push the changes. Git push remote. What's the name of the branch? This one. So git push remote paste, right? So let's try with request. Just a git push. Git push. So first of all, I want to take a look at one option that I copied yesterday without understanding what it was. -u. For every branch that is up to the successfully push, add upstream tracking reference. Okay. Options, the repository. So let's take a look at the sign. Hey. Okay, here. Sign. Sign the push request. Yes. Oh, if ask. The current branch has no upstream branch to push the current. Okay. Okay, so now we know that Codebug doesn't support signal pushes, so we remove this in the future. And now okay, yes. And this is something that is very interesting. because there is a branch directly here in code, and this happens also in GitHub, if I remember correctly. It directly gives you the shortcut to creating a new pull request. All right. So yes, these are the changes. Yes. And how do we name it? And all of the rest was in the next screen. Yes. So let's take a look at the shortcut that we took yesterday about how to do things in GitHub to link it to an issue. In pull request description. So it's close or resolve, because this is not just fix. Resolve. It doesn't close. I would use, yes, close. No, resolve. I'm going to use resolve. So, what does it say? One branch, like this, closes the tab. So resolve issue number 2. Let's see if there is a trick. This way. I start the title with work in progress to prevent the pull request from being merged accidentally. What do you mean? Okay, let's try that. I think that what it means is that if it starts with whip, then we can rename it without the whip, right? And let's do it. So now we have, it works. It links to the issue. It wasn't, but it says 3. Okay, no, doesn't matter. Oh, it's a pull. The third pull. It was a coincidence. All right, so we have this that we can edit. So we can edit the name. So this pull request can be merged automatically. This instance has no key to send is committed with. So let me stop for a second because all right, so it has a key, but maybe what I forgot is to use this key for signing. And check. Oh, that cannot be done. That's a shame. All right, so that means that I will need to create GPG key. And yes, we're not going to squash, we're going to keep the both commits. For more complex scenarios, it is a good idea to do a squash commit. A squash commit is still a merge, but it squashes all the commits into a single one. Right, but I think we're happy with that. So we're going to edit, remove the work in progress. It's not progress. Send to me. What happens if I add it to the project? I want to take a look at that. Oh, I see. It makes sense. So what happens is that typically the pull requests are reviewed, right? But because this is a one-man band, I'm going to do it without any reviews. This was feature. So we're going to remove from the project at the same label as we had for the issue. I think it's redundant, so I'm going to remove it. Okay, happy with that. So create merge commit, review on, merge pull, view on, and because I'm happy with that, I'm going to delete the old branch. All right. So as you can see now, in terms of issues, this has been merged. It has disappeared from the list of issues. It is marked here as complete, so we can move the card to move the card of the column there. And what else? So we will go to code. We don't have branches, and if I go to SRC, we have everything perfect. So that is the first pull request we have done to resolve an issue. That means that we're going to add a new issue that is part of this implementation. So what are we going to do next? So if we have implemented the mock encoder, what does it mean to implement the mock decoder? The mock decoder would receive symbols, but what can it create in the output? That's something I don't see. So we're going to directly jump and implement a compressor. 1 second. So don't know why the bitrate in Twitch is showing red. It's kind of unstable. Okay. Average stream bitrate too high. Unstable. Interesting. Anyways, you're going to implement a LZSS like compressor. We create an issue, and we have the issue in the dashboard. I kind of like how it looks like, because the issue got automatically solved, right? Was closed automatically. And it links to the issue and the pull request that it was merged. I kind of like it. So we're going to work on implementing the compressor. That means we need to create a new branch. But first of all, we need to move to the main branch. So that's something to remember. In remote, we don't have the branch anymore, but we have it locally. That's some cleanup that we need to do. And the way the branches were created, like this. Git C remote minus B is LZSS compressor. Okay, so now we're in a new branch. So we have finished that part. And that means that I'm going to take a screenshot of the new card. And update the card here. Beautiful. All right. So next, we need to create the compressor. So much like what we did with the coder, we're going to start writing the code directly in the LZSS until we find out what modules we may need. So obviously we need a compressor, and this class is going to have access to the encoder. Now, does it have the access to the encoder by value or by reference? So the thing is that, I remember correctly, if we get the encoder by value, then we lose the ability, we may lose the ability to then read the results in the mock encoder, because the owner would become the compressor. That means that your encoder has to be reference needs to be a reference. Okay, things are perfect. Missing lifetime specifier. That's correct. And now that is not used, that's correct. So We're going to do as we did last time, which is creating a compressor that owns the buffer. Later we will see how to use an external buffer. But at the moment, I think that we can work with an internal buffer. And as we did before, because it's a simple compressor at this stage, we're just going to use a vector. All right, so basically our compressor is going to be reading from the buffer, but it's going to split the buffer into two areas. One is the window. So this is already compressed. So the decompressor already knows the content of the window too. So it can be used to find matches for the references. And second, the comparison I don't want to use this slice. The comparison chunk. Sized at most maximum reference length that coded. So by having that amount of bytes, we can try to find the largest match possible. So the thing is, we need one index to split the buffer. Everything before is index. Not be compressed, and from this index onward, we're trying to find a match. All right, and because of that, we're going to call this is the next parameter above. We're going to have something called now. So where we are right now, that's that index. And that is what we're going to try to match. So basically, we implemented the compressor. The first thing that we will set will be the constructor. That needs to be past the encoder. we're going to start with any one. Doesn't matter. Now it's going to start from 0 because obviously everything before this has been compressed and everything before 0 has been compressed, nothing has been compressed. So this makes sense. Now, the next thing that we need, and at the moment I'm going to make it a public function. Maybe in the future I move it into a pub crate in order to be able to do some tests. But it's actually a private function. Is to compress current chunk, right? We need to compress this comparison chunk. Okay, so here we're going to describe the LZSS algorithm. This algorithm, what it says is that first we're trying to find a match. Okay, then if self is long is much long enough, in fact we're going to integrate that logic inside find match. So what we're going to do is that if the length is directly more than 0, we're assuming that we have solved the problem in find match. So find match only gives us matches that are long enough. Then in that case, we have a positive match, right? And in that case, what we need to do is to encode. So is for the encoder to write the reference or the length and then the distance. Now, this doesn't work because write reference returns an I result. So obviously we're going to propagate that. And what happens if that is not the case? That's not the case. What we need to do is to accumulate the first byte of this chunk into kind of a quote-unquote buffer. We're not going to use a buffer, obviously. But we're going to basically put it in a place. So at the end, we do find a reference. Everything that has been in that block of literals becomes a real literal block. So basically what it means is that here, when we do find a match, the first thing that we need to do is to flush the pending literal. So how are we going to do that? We'll see later, but it's basically we're going to need something more here. So now, by contrast, when we don't have a match, we accumulate the literal. Right, this is internal, it doesn't need IO, so I'm happy with that. Before we finish, there is something else that we need to solve. Is that if we are called again, typically find match is going to try to find a match over now. And if we don't advance now, because we have moved this by this amount of bytes or by one here, we're basically creating a forever loop. All right, so we need to modify now by length, and that means that that is going to fail, by the way. It's going to say that this reference needs to be mutable. And here, self now by 1. And with that, we are happy campers. Interesting. It is not complaining that I modify parameter when the reference is read-only. Interesting. Probably this is going to, yeah, because we don't have lifetimes. But there are a lot of errors before. Yeah, you see. So now this of this, find match doesn't exist, pending literal doesn't exist, and accumulate literal doesn't exist. So we're going to start with accumulate literal and flash pending literal. So in order to accumulate literal, the only thing that we need to do is the following: is keep track of where now was the first time we started accumulating literal characters. So the way we can do that is by copying now into pending literals, but with some, meaning we are accumulating. So after flash pending literal is called, we change pending literals to none, meaning we are not accumulating literals at the moment. So that means that in terms of initialization, pending literals need to be initialized to none. Yes. All right, so now we literal. The only thing that needs to do is if self pending literals is none, we are now starting to accumulate. Then self pending literals equals sum of now. No. So here we have an error, is that I'm trying to change something over in a immutable reference. Okay, which is the error we don't see here at the moment, we will see later. So that is the only thing that we need to do to accumulate minutes on literal. Now, as for flash and literal, and because this is flashing, is in some scenario needs to write things, I can foresee that we're going to have a result. Obviously, first thing that we need to do is that flash pending literal cannot be called if we aren't accumulating. So and this is part of our code. So it is only us internally who can make a mistake. So instead of an assert, I'm using a debug assert, which is kind of the conditional compilation that we use for the coder, right? Like here, but for an assert. So here we're going to assert that, come on, that pending literal is so. All right, you know we're not doing our job correctly when we're writing the code. After that, what do we need to do? Save and call the write the literal block, and that literal block is a slice. So that's basically the buffer between self-pending literals. Expect. So why am I using expect instead of unwrap? Because because it should work every single time. Right, so if it doesn't work, is because file to how do I write this? Oh, let me see. Oh, so fade to what? Expected so value for pending features. Start from here to save now. That is the block that we have been accumulated. Okay, and now we cannot borrow self-encoded as mutable as it is behind. Yeah, so basically this needs to be mutable. I think. Yes. All right, so with that, we have written the literal block. However, we need to do another thing, which is to reset the literal block. So self pending literals equals null. Now everything is fine. So okay. Cool, so now the only method that we haven't defined is find match. And this returns two axes, the length and the distance. Length equals 0. The longest match is still equal. And that is interesting because that means that the first thing that we need to do actually is to change the encoder API. So in case you were not here during my last era, let's not imagine, let's take a look at the basic algorithm, the LZSS. Right, so what it happens is that the data is compressed using references, right? And here we have a reference with size 3, with size 4, but not this with size 2. Why is that? So here what it says is assuming a break-even point of 2 bytes and those 2 byte pointer offset pairs. So what does that mean? When you have a length distance pair that is encoded into 2 bytes, if you have a match of only 2 bytes, you would be compressing it into 2 bytes. Best case scenario, we are starting a literal block instead, and those 2 bytes in a literal block take actually 3 bytes to express. Something like here, right? If I match here the I and the space, now everything is started from here, and this is on block anyway, right? And by extending that block by 2, we don't gain anything by having the reference. So when you have a reference with a length that best case scenario is the same number of bytes than literal, worst case scenario for a literal is it is its own literal block and it also needs some flag. And it doesn't make sense to compress. That's why in this case, assuming that you have a length distance pair that is encoded into 2 bytes, we have a break-even point of 2 bytes, right? So how are we going to we need to keep that in mind in this algorithm. But first, let's find a match. And we need to compare slices. So the next thing that I want to take a look at is slice comparison. Oops. So partial equality already compares the lengths. All right, so I don't know why I couldn't compare slices the last time. Anyway. So when we need to find a match, we need to compare every single possibility of the window with what we have starting from now. Right? So our goal is slice of the buffer between now and, for the moment, the end, but it doesn't make sense. Why is that? Because that means that if we manage to get the longest match ever in the window, the length of this match is going to be between now and the end of the buffer. However, we cannot forget that at the end of the day, the lengths and the distances need to be encoded in the example in the Wikipedia page. The pair of length and distance are to fit in 2 bytes, right? So imagine distances of being encoded in 1 byte and lengths being encoded in another byte. That would mean that the maximum possible length that can be encoded without an encoder failing would be 200. This encoder that is encoding length in 1 byte failing by giving invalid input would be 255. But what's the problem? The compressor doesn't know what is that value, what is the maximum length that can be encoded. So as I was saying, the first thing that we need to do is we need to add more code here. And returns the max, the length of the maxi that want to be encoded or a reference. Right, so we're going to call these then get max length reference, and obviously the output is going to be size. And I think that you can see that we're also going to need another for the distance, right? We cannot start finding matches from the start of the buffer until now. That is remember that's a window, because the distance, so the difference between where we found the match and now, that number may be over the maximum that can be encoded, which was also 255 in the example that we had before. So the compressor also needs to know that. Okay, but even before we move that, we move there, now you will realize another thing. What about literal blocks? For literal blocks, we are going to need to encode what is the amount of literal bytes that are going to follow, and then sending that many bytes. Meaning that our encoder may have a maximum length for this literal slice that can be encoded. So we need another function. And when we have this function, you realize that the implementations that we did for flash pending literal and especially accumulated literal is wrong. it has a flaw, because here we start accumulating literals, and maybe we're accumulating more than what flush pending literal can send in one go into red literal. So actually, what happens is that if length accumulate. Okay, if the accumulated length reaches what can be encoded, what happens? Let's see. Then we need to actually flush. And that means that we may need to propagate the error. And that is that here when we're accumulating, we need to also propagate the error. And now after we have done this, we need to start a new block with the now. Extrapolate this, we'll go. So, as you can see, one of the things that we need to do is changing this. Happens basically in two branches, right? Because we have one branch here, we have another branch here, and we will have an empty branch here. So what if we rewrite the function the other way around with a fast exit for the first branch, and then in one case we call this, and then in all the other two cases we call this. So let's max is max internal equals this, right? And now if self pending literal, okay, yeah, we cannot do this because we cannot call accumulated length in case of no for no. So if self pending literals is some and calculating the length that is based on pending literals, obviously. And if now the accumulated length is less than the maximum that can be accumulated, return OK and exit. So now, second branch, if self-pending is sum, then that means that we have accumulated the maximum. And now, as you can see, this line and this line are the same. So I like how this function is rewritten now. We have so many errors. It's all. All right, so accumulated length. Okay, so obviously here we have basically the same scenario as we had in Flash, right? This function should only be called if accumulated length is sum. And if that is the case, self now minus self-pending literals with this expect is basically that result, right? Is the accumulated length. All right. So now we have solved this particular problem with the literals. We're still here in find match, right? But before we move to find the match, what we probably will do in the next stream, I think that the first thing that we need to do is to implement these new functions in the mock code. Now, here comes the funny part. Is that this is a mock encoder. It can encode anything and everything, no problem whatsoever. If it's a new size, of course. So what we're going to do is to basically add these three parameters about the maximum length reference, the maximum distance, and the maximum length liter that I was thinking. Remember that when we were discussing the find match, we're talking about the break-even point, right? When a reference length is too short to be encoded as such. And if you think about it, it's just the same thing. It's another function that we need to create for the encoder. Get min break even left. Minimum reference length that encodes immense bytes than length enter bytes. All right, so what I'm going to do is I'm going to create an struct okay, the configuration that is going to have the break even length value size, the max reference instance size, max internal size, and the max distance reference view size. And only structure for get queries. And that means that now when we call new needs a new config. So now these four functions, because this is a mock, obviously, but the routine itself config break even length, so break even length, max reference, max distance reference, max length data. Okay, this obviously breaks all the tests. So what I'm going to do is to have the static configuration. Break-even length, let's say that is 3. Max length reference is going to make it 255. Max literal length 5. This also 55. So now here when we have encoder news, we add the configuration. Cool. This works. This works so well that actually we're going to do something else. Let me double check. So here we have points with the rest of the image. To be honest, we don't need to add tests for this because they are trivial. But now we can add tests here, right? Now it's not only if the length is equals to 0, but if the length is of a reference is smaller than the break-even length, the length is too small. In other case, if the length is larger than the max length for a reference, we also fail. Now because the length is too large, right? And for the distance, we have something similar. Yes, in this case, the smallest distance valid is 1, so the only value that is too small is 0. But then if distance is larger, so conf means distance for reference, we fail because the distance is too large. And for literals, we need to decouple the leaves. Like this, because now what we need to do is as if literal length is larger than conf the max length literal, then we fail. With literal is like is too long. All right, and because we have added those conditions. Now we need to add those to the tests. Right? So edge condition empty literal. Edge condition test, and then is to wrong. Yeah, the thing about that, we don't need to create multiple objects. So now max length literal, this one, which is the edge case. And this should fail. So at the moment, we need to release material group. Does it fail? So for literals, we have the two edge cases. This is left. So now left is config max length reference this one. And by the way, we need to also check the other way around, because sometimes I make mistakes. So I'm going to start here. Meaning that we need to test the edge condition maximum length. Hmm. Ah, so it's okay. All right, so what about references? For references, we are only measuring when the lengths are too small. And small is from break-even length onwards. So we're going to actually test all of them. The edge condition when the length is too large. Then condition break-even length. And the edge condition. Length, and that this one is going to require a new color. And now for the distances, the minimum distance, it happens like with the minimum liter length is just 0, so we have only a small test to do for the minimum. And for the maximum, when distance is too large, this fails. So now we have tests all around the edge cases, minimum maximums, and some feature cases for the tests. So let's train them. Oops. Failures. In right reference works, line 196. Oh yeah, I know why. Because this is the length. Same here and here and in other places, only that here is failing because of this. So I actually need to change this once for these values. Here, here, here. And let's say and that's it. That was all. All right, so now we have really harnessed the tests for a well-behaved set of rating functions for the encoder that is going to actually fail as soon as we make a mistake in the compressor and we're trying to send literals or references that are too small, too large, etc. To wrap up the session today, because it's past the time, today we have completed this card, basically everything except the first step, which was what we did yesterday. And now we're working with the implementation of the else of the algorithm. We have sketched the algorithm with regards to one position. Obviously, later we will need to create a method that iterates and increases now until the end of the buffer. But before we do that, we need to finish the implementation for accumulated literals had this catch that if we hadn't added this new function, it could absolutely have been able to flush literal blocks that were too large, right? And that is why I'm saying that in reality these tests for the real encoder only need to be done when here in debug assertion, so when we're optimizing. Reason being that we're already catching up the problems here, hopefully, when we're calculating the length, the accumulated length, etc. So if this is written correctly, this will not calling here the flash pending interval or in the other place will not make it fail. Now, with regards to finding matches, there are two things to consider. First is the maximum distance, which is going to be relevant here. Sorry, it's going to be relevant when we're looping all the different slices that we can compare with this, and the maximum length, which is going to be a factor here. And now I remember why we couldn't use comparisons, because comparisons is just yes, no. It doesn't give us the longest prefixes, and if I remember correctly, I didn't find the longest prefix in the library, but I will check it out again. In the meantime, yes, once we implement find match, that is going to take some time on the next stream, which I think is Monday. Then we need to add a function that loops until the full buffer is compressed, and that would be the implementation of this card of the compressor. And then we will continue with other things such as the mock decoder, so we can add the mock decompressor, and so on and so forth. All right, guys, so this has been I think a very fruitful session, even if I had this issue with this linked, not this one. With this link and how to create a pull request. But other than that, I'm happy with what we have done today, how much we have advanced today. So thank you very much for attending this session or for watching the video on YouTube, if that's your thing. And this has been the perfect danger. No. This has been the perfect Argent. No, correct. Signing off.